Number 12 then. Two functions are given by f and g here, and you have to find the composition of them and call that h for 2 marks. Well, that's not a lot. And then what? Differentiate it for another 2 marks. Dearie me. So that's just going to be f of, so f's going to act on 1 minus x cubed. And then what does f do? Whatever you feed it, that's this bracket. So there it is, 1 minus x, put the cubed in properly, to the power 5, raises it to the power 5 and adds on 3. And for that you're getting 2 marks. In part B it just said differentiate that. Well, h dash x, don't know if I should have rewritten that, but it's only just doing this quickly anyway, would be, now, it's a function of a function. So do the outer one first as you work your way in, as if that was just an x. If it was x to the power 5, you'd have written 5x to the power 4. But because it's not just an x, I'll have to keep what it's operating on to the power 4. And then what about the inner one? So what's the rate of change of this? It's the rate of change of the outer function multiplied by the rate of change of the inner one. So times, now that's a negative, so it'll be negative 3x squared. And of course that 3 disappears. And you just tidy it up. Numbers first, 3 5s are 15, then I'll put that in order of the simplest looking one first with the awkward looking bracket at the end. And that's it. So number 13 then, there it is, look. A decay equation, because that little negative exponent there. Radioactive substance, decays over time. M's the mass in micrograms and T is the time in years. A, for just the 1 mark. Determine the initial mass. Well, there it's there, 150. We'll need to work it out. And in part B, how long would it take to decay to 120? Well, that's really fairly straightforward. Out of all the questions you can get and logs and so on towards the end of paper 2, this must be like the easiest you could get. So the first part, what's the initial mass? Well, the initial mass will be when T equals 0. And at T equals 0, the initial mass, which you would call m0, would be, just use the formula, 150e to the negative, and you know all this is just going to disappear anyway, but times 0. And of course 0 here means e to the 0 is 1, so it's 150. So the initial mass is 150, and that was micrograms. And then in part B, how long does it take to get to 120? So I want 120 to be the answer when I evaluate this expression. Well, take that across and divide and you'll be left with this, but I think I'll write it the other way around first of all. So e to the negative 0.0054t will be 120 over 150. Get rid of those zeros in the next line. Now, just use the inverse. If that's what e is equal to, then that part, 0054t, will just be ln of that. I'll just knock that down to 12 over 50. I could have knocked it down further, but you're going to use your calculator anyway. And then finally, t is going to be that. I'll just leave it as 12 over 15, divided by 0.0054. So now it's just press the buttons and you get the answer. And when you do that, you get 41.322 and so on. So what we call that? 41.3, and that was in years.